Welcome to this session. In this session, we discuss specifically about residue at infinity. So residue of a function f of z at z equals to infinity is defined as residue at z equals to infinity is negative 1 over 2 pi I integral along C of the function f of z dz, where C or the integration is taken over is taken around C in anti-clockwise direction. So that's how we define residue of a function f of z at infinity, that you define by the formula negative 1 over 2 pi I, then the integral along C of the function f of z with respect to z. And then C is a large circle containing all finite singularities of f of z. So that's how we define residue at infinity. So I'm going now to give, in a summary, different methods of finding residues of functions. So methods of finding residues. I'll state without proof, but you can always get the proof for the same. So the first one, we call it A, residue at simple pole. So let's see how we calculate residue at simple pole. So there are two things, or there are two ways. So one, if the function f of z has a simple pole, at the point z equals to a, then the residue of the function at a is given by limit as z approaches a of z minus a times the function f of z. So that's how we find residue of a simple pole z equals to a. Then next, So this is the main formula. So next, if now the function we are dealing with is of the form at B or Roman 2, if f of z is of the form f of z equals to phi of z over psi of z, where this function in the denominator, when you put the value of the pole, you get 0. This to mean at a equals to 0. But if you put a in the numerator, you get non-zero value. Then the residue of the function at z equals to a is given by defining the value of the numerator at a, and then you divide by the derivative of the denominator at a. Or we can write residue at z equals to a is given by phi at a over the derivative of the function at the point a. So that's how we define residues of functions at simple poles z equals to a. And then B, another method of finding residues, B, residue at a pole of order n So let's see how you find residues of a pole of order n. So you say if f of z has a pole of order n at the point z equals to a, then residue at z equals to a is given by 1 over n minus 1 factorial, and then you multiply by the n minus 1 derivative of the function with respect to z, and the function is z minus a power n. You multiply by the function f of z. So this is how we define the residue of a pole of order n. So this is a formula. And then C, the second last method of finding the residues. So C, residue at a pole z equals to a of any order. So it may be simple or, so simple are those poles of order 1, order m. It's like this is a general way of defining a pole of any order at the point z equals to a. So you use the formula residue of the function f of a is given by coefficient of 1 over t, where t is given by z minus a. So this is how we define residue of the function at the pole z equals to a. So we just define the coefficient of z minus a, or simply coefficient of the reciprocal of z minus a, or reciprocal of t, where we define t as z minus a. And then d, residue at z equals to infinity. So is given by residue of f of z at infinity is given by minus 1 over 2 pi I integral along C f of z dz. So that's how we define the residue of a function f of z at z equals to infinity. So the next session we will be doing examples on how to find residues, applying these 4 different methods we have discussed. Thank you.